In this lesson, we're going to take a look at atoms and ions. Now, we know atoms are neutral because they have the same number of protons and electrons. An ion forms when an atom has gained or lost electrons, so it's charged. And this happens because, remember, only the noble gases have 8 valence electrons and are stable. The rest of them would like to look like those noble gases, and they can do that by gaining or losing electrons. So ions can be positive or negative. We write that they could be like a 2+, so they have 2 extra protons compared to electrons, or like a 3-, they have 3 more electrons than protons. So we're telling us what the charge of the ion is with the number and then the plus or minus. Ions are not neutral because the protons and the electrons no longer balance. And it's not because protons were gained or lost, it's because electrons were gained or lost. So gaining versus losing electrons. If I gain an electron, I started with equal numbers, say like 11 protons and 11 electrons. If I gain an electron, now I have 12 electrons. That's 12 minuses to 1 plus, and so that's going to give me extra negative. This is an anion. It's a negative ion, so if I add electrons, an ion becomes negative. Now the opposite is true if I were losing electrons. So if I have 11 protons and 11 electrons and I take one of those away, so I end up with only 10 electrons, now I have more positives than negatives, and this results in a positive ion called a cation. That's an O, called a cation. Anyways, what's the difference between an atom and an ion? The charge. Atoms are neutral, they have no charge. That's because they have equal numbers of protons and electrons. This is no longer the case with ions. They have either a positive or negative charge because they have gained or lost electrons. Why do ions form? Ions form because atoms are unstable if they don't have a full valence shell. Remember, their s and p orbitals want to be full, and there's 1 s orbital and there's 3 p orbitals. That's 2 electrons here, 6 electrons here. That's 8. That's why it's called the octet rule. It's 8 valence electrons. That's stable. You'll notice this atom right here has 1, 2, 3, 4, 5, 6 valence electrons. It's got an open spot here and an open spot here. It could take 2 electrons. Now, if it does that, if it puts 2 electrons in here, it's no longer neutral because its protons will no longer balance its electrons, but it does have a stable electron configuration. And it will be a 2- ion because it took in those 2 extra electrons. The octet rule says once we get to 8 valence electrons, the atom is stable. So one of the ways they can do that is by actually gaining or losing electrons. Why would they lose electrons? Well, if instead of having an abundance of electrons out here, if there was, you say you had your first 2 electrons and then you had your next 8, 2, 4, 6, 8, and then I had on my outer energy level I had 1 or 2 or 3 of these, it's easier to give that one away than fill in all the empty spots. And then I just have this shell here that does have its 8 valence electrons. So does the identity change? No, because the protons don't change. It only changes to an ion. Now ions do have different properties than the atom that's neutral. Oxygen. Oxygen has 8 protons. So I'm going to put 8 protons. It says oxygen 17. 17 minus 8 is 9. So I have 9 neutrons. And then it's got 8 electrons. The first electrons go on the first energy level. That's just the s orbital. It only holds 2. The next electrons can fill the s and p. So I've got to get all the way to 8. So there's 3, 4, 5, 6, 7, 8. Okay? You'll notice there's an open spot here and an open spot here. Oxygen only has 6 valence electrons, not 8 valence electrons. So what this will mean is if we look at the electron dot diagram of oxygen, it's a whole lot easier to see this. So we go 1, 2, 3, 4, 5, 6. And we can see those 2 open spots. So 2 electrons will fill in there, and we'll get oxygen that has 2- charge, and now it does have all 8 valence electrons. So this is a nonmetal. It formed a negative ion, and it took in 2 electrons to do that. Okay? And there's actually patterns on the periodic table that are going to help us do this. So let's look at a metal. So magnesium has 12 protons. We can look at the periodic table. 24 minus 12 is 12 neutrons, and it's also going to have 12 electrons. So there's our first 2, and then we can get 8 on our second energy level. 2, 4, 6, 8, and we need 2 more electrons because we need a total of 12. 1, 2. Okay. Magnesium actually will get rid of these 2 electrons. So we started with magnesium. Here's our electron dot diagram. 2 valence electrons. It gives these away and ends up magnesium, but now it's got 2 more protons than electrons. This is a metal. It's in the second column, right? And so we end up with magnesium 2+ because those electrons were given away to make this thing have a stable configuration, because now what it is this. It's got these 8 valence electrons on the second energy level instead of 2 valence electrons on the third. Neon has 10 protons. Neon 21 would have 21 minus 10 is 11 neutrons, and it also will have 10 electrons. There's 2 on the first energy level, 1 here, and then 2, 4, 6, 8. And that's actually stable. And if we look at neon's electron dot diagram, we can see 1, 2, 3, 4, 5, 6, 7, 8, no ion. It will not form an ion because it's already got a stable configuration. So let's look at the pattern that's going on here. We know everything in column 1 has 1 valence electron. Everything in column 2, 2 valence electrons. 3, 4, 5, 6, 7, 8, except for helium, which has 2. And we know all of these are stable. Okay? Well, it turns out this thing right here, these non-metals, these are 1 electron away from being stable. So they'll add an electron and be a -1 ion. 1 minus ion, 2 minus ion, 3 minus ion. We don't usually see ions form through here. It's possible, especially when you get down into these metals, but we'll ignore those for now. These ones are actually closer to dropping in energy level, so they'll do a 3+, a 2+, and a 1+. So what we see is metals form cations, and that means they lose electrons. And nonmetals, being closer to the noble gases over here by gaining electrons, nonmetals form anions. And that just means they gain electrons. So, quick few more examples and then we'll be done. So calcium, all we got to do here is get our electron dot diagram and tell us about the ions. So calcium starts with 2 valence electrons, and I know that because it's in column 2, and then it gives both of those away, which ends up a calcium 2+. So this is a reactive element, and it reacts to form a 2+ ion. It is a metal. We know that because it's on the left side of the periodic table. Phosphorus is over in group 5. It's got 5 valence electrons. It is reactive. It is a non-metal. And because it's a nonmetal, it's going to fill in these 3 spots, which gets it phosphorus with 8 valence electrons, filling its s and p orbitals, and that's phosphorus 3- because we had to fill in 1, 2, 3 electrons, and so that's an anion, nonmetal. Now xenon, if you find xenon, it's over in column 8. It's a noble gas. It's got 8 valence electrons. It's stable. Does not react, and so it doesn't have an ion. Indium's a little bit harder to find. It is actually a group 3 metal. It's right below aluminum and gallium, and so indium has 3 valence electrons. It will give all 3 of those electrons away and form indium 3+. It is a metal, and it's a 3+ ion, and it is a positive ion, so we call it a cation.